Hi scholars, today we're going to talk about the relationship between percentages and decimals. So as a starting point, percentages can be considered as a part-to-whole comparison. So let's take a simple example. Here we have 5 balls, so that would be the total, the whole number of balls. So we can say out of 5 balls, how many are red? Well, okay, there are 3 that are red. So this is a part-to-whole fraction right here, right? 3 out of 5. Now percents, to work with percents, what we want to do is we want to see if this ratio held. If for every 5 balls, 3 of them were red, we want to say how many would be red out of 100, right? Out of a whole mess. What about if we had all 100 of these balls together? How many would be red? And so we can write that sort of, mathematically as this is actually a proportion, right? 3 over 5, 3 out of 5 is how many out of 100. Okay, and we can solve, cross multiply if we want, reason proportionally, and we find out that this value of x is 60, and this means that 3 out of 5 is the same as 60%. Okay, so now we have this nice relationship that a percent is nothing more than a part-to-whole ratio where the whole is 100, and the reason why it's 100 is, well, it makes sense. So let's think. Let's say if I tell you that I have 100% of my sneaker, let's say, what does that mean? It means I have one of my sneaker. I have the whole thing, right? 100% of something is the same as saying one of something. Now this is really important. This is where we start when we think about converting percents into numbers, into decimals, right? And we want to be able to do this because we want to be able to operate, right? If I talk about 100%, I can't really do 100% times something or divided by something. It's not a number, right? It's built in. There's a ratio here. Built into a percent sign is this ratio here out of 100. And so I want to find a quick and easy way to convert that into a number, and once it's a number, I can operate with it. So this is our home base. Okay, this is home base, and what we can do now is reason that if I want to talk about something that is less than 100%, for example, 60%, if I say, what kind of a number would that be? It would have to be a number that's less than 1. We're going to learn it's 0.6, in fact. And if I say I wanted to do a number that's bigger than 100%, 140%, it's going to have to be a number that's bigger than 1. We're going to learn it's 1.4, okay? And we can think about, how do I turn a percent into a number? Well, if I start with 100 and I end up with 1, what did I do? I divided by 100 to move from a percent to a decimal, to a number, right? So in this direction, I'm dividing by 100. Well, what about in the other direction? If I have a number and I want to get to a percent, I'm multiplying by 100, okay? And that makes sense with this original definition. This is the original definition of a part-to-whole relationship. So let's take a look at a couple of examples there, because this is a way, you can always solve percent problems by setting up a proportion. This is very true, and you can cross-multiply, but there's a shortcut, okay? So this is correct, but there's a shortcut. So let's take a look at what the shortcut could be. For example, rewrite the following decimals as percentages. So 0.57. We could do it the long way. I could say that 0.57 equals x over 100. I could say this is really 0.57 over 1. I could cross multiply, and you would end up with x. This would lead to x equals 57, which means 57%. So you could do it the long way. However, look, 0.57, essentially, when you're cross-multiplying here, you're multiplying 0.57 by 100. And we know how to multiply things by 100 easily, right? By 100 means it's getting 100 times bigger, so I can take this decimal point and immediately move it over twice. And this turns into 57%. And I didn't need to write a proportion, right? This is a shortcut. These are shortcuts that we're learning here, okay? So this is a shortcut. And this principle of translating the decimal into a percent by moving the decimal place over to the right twice holds no matter what kind of number we have. So let's take a look at this one, number 2. Here we'll even use a different color. 2.15. So there's my decimal points. I'm going to move it over twice. It lands right here. And I'm going to say that 2.15 is the equivalent of 215%. Now this should make sense. If I have 2 of something, it's like having 200% of that thing, right? If 100% is 1, it makes sense 200% is 2, and so this is a little more than 2 of something, okay? So yes, you can have percents that are over 100%. Uh-oh, this is tricky. There looks like a even really small number with a 0. No, it's the same procedure, right? If you can do something on this number, you should be able to do the same procedure on any number, okay? So here's my decimal point. Let's move it over once and twice. The decimal point now lands in between the 3 and the 5. That's okay. That means this represents 3.5%. And lots of times students will say, wait a minute, I have a problem because I thought we were talking about the percents, and here's a decimal point in the 3.5. That's okay. You can have fractions of percents. You can have less than 1%, right? You can have 0.5%. That is okay. It's entirely legitimate. So the answer here is 3.5%. Let's take a look at one more. We're going to do the same thing. The decimal point is here. I'm going to move it once and twice. It lands right before the 6. So the answer to this is 0.6%. That's less than 1%. I might want to write 0.6% just to make sure, because sometimes the decimal point may be unclear on the paper or something like that, but the answer is 0.6%. So that's how to convert decimals into percentages. Let's go in the opposite direction. Rewrite the following percentages as decimals. So 94%. Again, if I want to do it the long way, I could say that I set up my proportion 94 out of 100, right, equals x, and I plug this into my calculator, 94 over 100, and in fact I would find out that x equals 0.94. However, clearly, right, if there's a relationship between this number and this number where we don't need to set up a proportion and solve it, okay? We can actually just immediately use the decimal point trick. Well, to move from a decimal to a percentage, right, we move the decimal point to the right. So to move from a percentage to a decimal, we're going to move it 2 to the left, right? We're going to make the percent a smaller number, and this makes sense. 94% is less than 100%. So the decimal has got to be less than 1. Remember, our home base is that 1 is the same as 100%, okay? These things are the same. So 94%, here's my decimal point. Let's move it over once, twice, and my answer is that equals 0.94. Let's keep moving really quick now, right? There's my decimal point. I move it over once, twice. Got to fill in, right? 0 here. So this number, 0.2%, is really 0.002. If that's a decimal, I wanted to write it as a decimal. 8.25%, same principle. Move it over 0, 0. Move it over twice. Add a 0. This is equal to 0.0825. 349%, where there's that decimal point. Okay, it's right at the end of the 9. Gonna move it over once, twice. Stops between the 3 and the 4, and that equals 3.49. Now the value is that all of these are numbers. These I can operate with. I can operate with these numbers, okay? So let's take a look at an example of that. Just a very brief example. Okay, 30% off. So you go to a store, there's a pair of jeans. It used to cost $50, let's say, but no, the sale is 30% off. How much does it cost now? Notice, I can't take this number 30, and immediately multiply it by 50 or divide it by 50. I can't do that because the 50 is talking about dollars, and the 30 is this 30%, okay? So my first step in all of this is going to be to convert a percent into a decimal. Well, now we know how to convert 30% into a decimal, right? We just did that. We moved over once, twice. So 30% equals 0.3, right? Because I moved the decimal place over twice. That's where it lands. This is a number I can deal with. The next step to think about is 30% off. Well, it was 100% of its price. That's what it started with. And then I took 30% off. So how do I represent taking money away in math. Minus, right? I started at 100% of my price, $50. I took away 30%, okay? So this represents the sale. This is the sale. 1 minus 0.3, we can put in the calculator, is in fact 0.7, and this makes sense. Now, this is 70% of the original price. That should make a lot of sense. If I take 30% off, 70% is left. And now I'm in a process where I can actually calculate what this sale will do to this initial price, right? So I started with $50. It used to cost $50. Now it costs 70% of that $50. What does that end up being? You can plug it in your calculator. You'll get $35. Okay, so that's how we can use this idea of changing percents into decimals in order to operate on them, right? That's how we can do it with a sale. Okay, let's take a look at one other way in which percents show up in the real world, and that has to do with savings banks, right? So if you go in, you open up a checking account or a savings account, they're going to tell you, we will pay you. If you give us your money, we will pay you some amount of interest, okay? 2.5% of interest, because you're giving us your money. So we want to thank you for that, right? And so the question is, if I put in, let's say, $100 and I got 2.5% interest, how much money would I have right after I got that interest? Let's say it took a year, right? How much money would I have after a year? Well, again, I can't say 2.5 times 100 or divided by 100. No. This number, before I deal with it, I have to change the percent into a decimal, okay? So we know how to do that. So 2.5%. We can go once and twice like this, put a 0, and this is going to equal to 0.025. Okay, so this is our first step. And again, right, it's not saying that they're only going to pay me 2.5% of the money that I put in, right? That would be like, I get back $250. I put in $100, I get back $250. That's a terrible deal, right? They're saying that in addition to the whole $100, 100% of that money, I'm going to add an additional 0.025%, right? Or 0.025, which represents 2.5%. So this right here is, right? This is my starting, what I start with, right? We always start with 1, right? 100% of the money. And then this is my interest. And so if we say, well, after 1 year, if I started with, if I have $100, what would I end up with? You do the math and you end up with $102.50. Okay, so after a year, this savings account will make you $2.50.